It's no secret that there's plenty of friendly rivalry between the Subaru and Mitsubishi camps when it comes to import four-wheel drive drag racing. Unfortunately for Subaru owners though, currently the Mitsubishi camp is firmly winning, with plenty of examples of the Evo in the 8 and even the 7 second bracket. Brandon, however, is intent on levelling the playing field a little bit with his 1030 wheel horsepower English racing built 2013 Subaru STI. Brandon's already no stranger to the drag strip, and on a previous build with a smaller turbocharger, the car's already clocked a PB of 950 at 145 mile an hour. However, over the off-season, the English racing team have been busy adding a few new elements to this car in order to make it even quicker, pushing towards the 8 second bracket. Since this is a US domestic market car, the STI is equipped with the EJ25 2.5 litre engine block. Given the 1,000 plus horsepower targets though, clearly that factory engine was never going to be up to the task. So the team at English Racing went with an IAG Stage 4 block. This includes closed decking of the block, and this is one of the big problems with an open deck block design, in that the sleeves or cylinder liners aren't physically attached or connected to the outside of the engine block. Now this is fine for factory power levels, but once we start running a lot of boost, this means that those sleeves can actually move around and flex, particularly under the high combustion pressures we see at high boost levels. This can cause problems with the sleeves cracking, and it can also end up with head gasket integrity issues. IAG fixed this by inserting a block plate that physically connects the outside of the block to the cylinder sleeves. On top of this, the block is also fitted with a Manley crankshaft, Manley steel rods and Manley forged pistons. A big problem with any high boost engine is head gasket integrity, and to address this, English Racing have fitted a stainless steel O-ring into the engine block, and this is used in conjunction with an MLS or multi-layer steel head gasket. That O-ring just provides a little bit more clamping force for that head gasket and just gives a little bit more integrity to the head gasket seal. This is also aided by a set of oversized ARP 14mm head studs. The block itself really doesn't make power though, and it just needs to be built to support the kind of power and rev range that the engine builder is expecting. It's the heads where we really have a lot of influence over the airflow into and out of the engine, and hence how much power that particular engine can support. Here the team from English Racing went with a set of Head Games hand-ported heads. These are fitted with oversized valves, and they're topped with a set of GSC S2 cams. This is also matched with a set of GSC valve springs. Now those S2 cams are actually a relatively small profile. They're around about 272 degrees of duration. So these are quite a streetable cam, and it's actually quite surprising that the team have managed to extract over 1,000 wheel horsepower with what is such a small cam profile, despite the fact that they are revving this engine to 9,000 RPM, well beyond where that S2 cam is really in the meat of its performance. One of the common reliability problems with Subaru engines is around the bearing life, and part of this comes down to the relatively small size of the connecting rod big end bearings. To help improve bearing life and ensure a consistent supply of high pressure oil to the engine bearings, even under the high loads associated with drag racing, the English Racing crew fitted a Magnus Dry Sump Kit, and this uses a Peterson dry sump pump. This draws oil from an external oil reservoir and makes sure that regardless of the cornering, braking or acceleration forces that the engine is experiencing, the bearings are always going to receive a constant supply of high pressure engine oil. Topping the engine is a Process West CNC machined intake manifold, which is fronted with a Boomba 74mm drive-by-wire throttle body. The fuel system is supported here with a set of 8 Injector Dynamics ID2000 injectors, which are fitted to an Illuminati dual injector TGV delete system. Now, the reason that 8 injectors are fitted to this engine is to do with the fuel it's running. In this case, English Racing have tuned this engine to run on M1 Racing methanol fuel. And with methanol fuel, in rough terms, we need around about 2.5 times more fuel flow to make the same sort of power that we'd be seeing on pump gas. So this requires a complete rethink of the entire fuel system strategy. To make the engine still start and idle nicely, and under low load conditions only a single set of injectors are operational, and then as the RPM and load increases, the second set of injectors are staged in. On Brandon's previous build, when the car ran its 950 quarter-mile pass and produced 930 wheel horsepower, it was fitted with a Precision 6870 turbocharger. In the off-season, English Racing have upgraded this for a significantly larger 7685 Precision turbo. Now, despite stepping up to that larger turbo, at the same time they've also swapped from ethanol fuel through to M1 methanol. And that change to the methanol fuel has actually resulted in the larger turbo spooling almost exactly the same as the small 6870. So it's given nothing away in terms of bottom end response. Making lots of power is great, but we also need to provide a reliable drivetrain to get that power to the ground. In this case, the engine is backed up by an Exedi triple plate clutch, and this feeds power into a PPG dog engagement first to fourth gear set that's fitted inside the factory Subaru 6-speed gearbox. And it actually still retains the factory 5th and 6th gear, which can be used when the car is being daily driven. Now, topping the gearbox is a H-pattern gear lever, and this is fitted with a strain gauge gear knob which allows clutchless shifting on the drag strip. Power is delivered from that gearbox to the rear differential thanks to a carbon fibre drive shaft shop drive shaft, and all of the axles are also sourced from the drive shaft shop front and rear. The electronics package controlling the car is based around a Motec M1 ECU, and this is fitted with a John Reed Racing firmware package designed specifically for the Subaru platform. This means that a lot of the factory functionality is retained, such as the operation of the factory gauge cluster, as well as all of the buttons on the factory steering wheel, functions such as the stock cruise control, as well as the SI drive functionality that now allows multiple throttle maps to be selected, as well as multiple boost pressures to be selected. The Motec M1 ECU provides some pretty advanced control options for the engine, including the staged injection that we've already briefly touched on. It also uses a Motec LTC or lambda to can input, which provides air-fuel ratio data. This is useful for speeding up the tuning process, but once the engine is tuned, you've also got the option here to use full closed-loop control of the air-fuel ratio down the drag strip. This means that the ECU can automatically compensate for any small changes in air-fuel ratio and make sure that the engine remains reliable. In terms of safety functions, the Motec ECU also monitors the engine oil pressure, and this allows the ECU to instantly cut the engine if the oil pressure drops to a level that's deemed to be unsafe. Fuel pressure is also monitored, and this allows the ECU to automatically make adjustments to the injector pulse width to compensate for any fluctuations in fuel pressure. This makes sure, within reason, that the correct volume of fuel is being delivered to the engine, even if the fuel pressure isn't exactly where it was when the vehicle was tuned. The last safety function is a coolant pressure monitoring system, and this allows the ECU to monitor the pressure in the cooling system. And why this is important is that if the head gasket starts to leak, this will show up first of all because the pressure in that cooling system will spike due to the combustion pressure entering the cooling system. Again, this allows some safety precautions to be put in place to cut the engine and prevent more significant damage occurring to the engine. Well, this is a brand new combination for this season racing. A dyno-proven 100 horsepower increase over the old setup, combined with a 300-pound reduction in weight, can only add up to improved times. And we look forward to seeing what Brandon can do with this car once it's unleashed on the drag strip. That video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.